Corps of Engineers has served this nation since 1775, and its research and development mission supported the military since World War II. Our labs were formed decades prior, and few people know that we enabled critical operations at D-Day, such as the amphibious landings at Normandy. We advise leaders on challenges that they may encounter with coastal logistics, and we executed scaled models of the Mulberry harbors to understand their response during high sea states. We did scaled testing of float bridges and advised the Army on which variants perform better in rough conditions, and were the originators of airfield engineering for military operations by addressing the specialized heavy wheel loads that those platforms deliver. The mattings used to expand those airfields were developed here and continued to be improved to this day. Our unique perspective on intelligence of world-class and austere port locations and how the weather impacts military operations is critical when engineering solutions that cross domain boundaries. So if you're moving from the sea to the ground or ground to the air, each require an engineered solution. In the future, we'll continue to advance the state of the possible by developing modern methods to cross these boundaries. We simulate amphibious vessel landings in true environments. We virtually evaluate ground vehicle movements and the timing further inland. We've also modernized techniques to collect real-time bathymetry using low-cost sensors so that we understand degrading coastal conditions before they hinder military operations. And if those conditions are not conducive to the military's needs, we've developed robotic dredges to manipulate the environment into something more compatible with watercraft vessels. We've developed new models that can predict how our causeways will operate in extreme sea states to better inform go, no-go decisions on when operations should cease. And if bare beach operations are abandoned and we need access to a full port, we've delivered semi-autonomous reconnaissance vessels that accelerate our dive team's hydro survey missions. Our Navy partners have jointly engineered solutions with us to rapidly repair ports to offload our military fleet in tight operational windows. In the ground domain, bridges have always been strategic choke points and served as military targets in all conflicts. Our deep knowledge of structures is being used to develop new bridge reconnaissance techniques, using sensor modes in ways that have never been done before. Understanding that the enemy will also attempt to further restrict our movements, we're advancing the Army's capabilities with items like the robotic breacher. This limits the combat engineer's exposure during dangerous missions. Eventually, the sea and land domains will be difficult to maneuver through, so modern methods to open the air domain are needed, such as expedient airfield damage repair, site selection of helicopter landing zones, and other ways to get our forces to the fight through the air. Other obstacles, such as river crossings, must be executed with extreme precision and timing, so we're developing world-class methods to provide 14-day forecast of global river levels and engineering solutions to expand our float bridge performance, including the matting required to get our vehicles out of the riverbanks. So the bottom line is that ERDC continues to deliver solutions that will help us win in multi-domain operations. We did it in World War II, and we know we can do it again because we have great engineers and scientists on board to make it happen. Let us try.